In 2016, marine biologists on the Washington coast did something that other scientists called reckless. They captured 64 sea otters from a healthy population 400 miles north and released them into a bay where the seafloor had been dead for almost 30 years. No kelp, no fish, just a gray wasteland of spiny purple sea urchins stretching to the horizon. Fishing groups called it a threat to their livelihood. Marine ecologists said the otters would starve within a year. There was nothing left down there to eat except the urchins, and urchins alone couldn't sustain a population that size. Local boat operators predicted the otters would simply swim back north the moment they realized the bay was empty. Everyone agreed it was a desperate move by a team that had run out of better options. 8 years later, that 15-mile stretch of coastline is unrecognizable, and researchers are calling it one of the fastest marine ecosystem recoveries ever documented. This is the story of how an animal that eats 25% of its body weight every single day turned an underwater desert back into a forest, and why coastal governments from Alaska to Chile are now trying to copy it. Before we get into how they pulled it off, if you're into stories about nature quietly fixing what we broke, subscribe because we post one of these every week and you don't want to miss the next one. Let me paint you a picture of what that bay looked like in 2016. The area sits along a sheltered stretch of the Washington coast that had supported a dense kelp forest for thousands of years, towering underwater canopies that sheltered rockfish, salmon fry, and dozens of invertebrate species. Sea otters had lived there too, until fur traders wiped them out in the 1800s. Without otters to hunt them, sea urchin populations exploded unchecked for over a century. Urchins eat kelp holdfasts, the root structures that anchor the plant to rock. By the 1980s, the urchins had eaten through nearly the entire forest. What was left behind is what marine biologists call an urchin barren. Purple urchins carpeted the seafloor at densities of over 60 per square meter. Packed so tightly, divers described walking across them like a spiky pavement. There was nothing left for the urchins to eat, so they simply stopped growing, entered a kind of biological standby, and waited, some for over a decade, in a state scientists call zombie urchins, alive but essentially empty, with almost no reproductive tissue left inside them. Fish that depended on kelp canopy for shelter disappeared. Juvenile salmon lost a critical nursery habitat. Commercial crab populations collapsed because their larvae had nowhere to hide from predators. Even the water itself changed. Without kelp fronds slowing the current and trapping fine sediment, the bay grew murkier every year, and dive visibility that used to run 40 feet dropped to under 10. Aerial and sonar surveys in 2015 found almost zero structural habitat across 15 miles of coastline that used to be one of the richest fisheries on the Pacific coast, and local charter captains had stopped bringing clients to the area entirely because there was nothing left worth showing them. Traditional restoration options were grim. You could try transplanting kelp directly, but urchins would eat any new growth within weeks, sometimes within days of a dive team leaving the water. You could attempt mass urchin culling by hand, divers physically smashing them one by one with hammers. But a single acre took a two-person team nearly a full week to clear properly, and the urchins simply crawled back in from surrounding barrens within a season, undoing months of work. A pilot culling program in a nearby cove had already burned through $4 million over 6 years and covered less than 3% of the degraded coastline. Divers on that project described it as bailing out a sinking boat with a teaspoon. At that rate, restoring the full 15 miles would take over a century and cost close to $200 million, with urchins likely recolonizing behind the crews before they even finished the first pass. Then a marine ecologist named Dr. Owen Fraser proposed something that sounded almost lazy by comparison. Stop trying to remove the urchins ourselves. Bring back the animal that evolved to do it for us. His reasoning came from decades of otter research along the Alaskan coast, where otter populations had never been wiped out. In those areas, kelp forests remained thick and healthy because otters kept urchin numbers low simply by eating constantly. One otter can consume thousands of urchins a year, But Fraser's critical insight was that otters aren't just predators, they're a keystone species, meaning their presence or absence restructures the entire ecosystem beneath them. Remove otters, urchins explode, and kelp disappears. Put otters back, urchins collapse, and kelp returns on its own, no transplanting required. The plan was to capture otters from an overcrowded colony where they were competing hard for food and release them into the barren with nothing waiting for them but urchins. No supplemental feeding, no fenced enclosures, just release them and see if they could survive on a food source everyone assumed was too depleted of nutrition to sustain them. The budget was $940,000, almost entirely for capture, veterinary checks, transport, and 4 years of tracking. Compared to the $200 million culling estimate, it was a rounding error, but almost nobody expected it to work. The state approved the release in March 2016. By July, 64 otters had been relocated across 6 sites along the barren. Then came the waiting. The first 6 months looked like exactly the disaster critics had predicted. Tracking tags showed nearly a third of the otters swimming north within weeks, apparently searching for better foraging ground. Several were found stranded or in poor body condition. The urchins the otters did eat were small and nutrient poor from decades of near starvation, and early necropsies on 2 otters that died showed signs of malnutrition. By that October, fishing associations were demanding the program be shut down, calling it inhumane to release animals onto ground that couldn't feed them. Local news ran segments about another failed government experiment. Fraser was hauled in front of the county commission twice that winter to defend the project. But by month 5, something shifted. Trail cameras and diver surveys started showing a pattern nobody had planned for. The otters that stayed weren't eating urchins evenly across the barren. They were clearing tight, concentrated feeding zones, working through dense urchin clusters, one patch at a time, rather than spreading thin. Inside those cleared patches, something remarkable happened almost immediately. Microscopic kelp spores that had been drifting in the water column for decades, unable to attach to bare rock covered in living urchins, finally found open substrate. Within 8 weeks of the first cleared patches appearing, divers documented the first new kelp blades in that bay in over 30 years. Tiny, but alive. By early 2017, those cleared feeding zones had grown from a few square meters to patches the size of a basketball court, and the kelp inside them wasn't struggling anymore. It was growing over a foot a week, which is close to the fastest growth rate of any plant on Earth. And here's where the feedback loop kicked in. New kelp canopy created shade and structure, which brought back small fish and invertebrates, which gave otters an easier, more varied diet, which meant they didn't have to travel as far to eat, which meant they stayed in the area and kept clearing urchins at the edges of the new forest, expanding it outward like a slow green tide pushing back the gray barren. By the end of 2017, aerial surveys showed the first cleared zones had merged into patches covering roughly 40 acres. Rockfish that hadn't been seen in that bay in decades started showing up in survey nets. Juvenile salmon began using the new kelp edges as a migration corridor. A colony of harbor seals that had abandoned the area in the 1990s was spotted hauling out on a nearby rock for the first time in over 20 years. By 2019, 3 years after the release, the otter population had grown to 91 individuals, meaning they were successfully breeding on a food source everyone had assumed was too poor to support reproduction. The kelp forest had expanded to just under 900 acres, roughly 12% of the original barren. Fish biomass surveys inside the restored patches were already approaching levels found in kelp forests that had never been degraded at all. By 2021, the numbers stopped sounding believable. The otter population had climbed to around 160, spread across 11 distinct territorial groups. Kelp coverage had reached just over 4,000 acres, more than half the original 15-mile stretch, and satellite imagery showed canopy visible from space for the first time since the 1970s. Commercial crab landings in the surrounding area had risen 60% compared to the 2016 baseline, because crab larvae finally had kelp structure to hide in again. The The total cost from 2016 through 2021 was just under $1.4 million, a fraction of what a single year of manual urchin culling across the same footage would have cost. By 2023, marine biologists from Japan, Chile, and South Africa were visiting the bay to study the model firsthand. What they found challenged one of the basic assumptions of restoration ecology, the idea that you fix the physical environment first and let wildlife return later. Fraser's team had done the opposite. They put the missing animal back first and let the animal rebuild the environment. Soil, or in this case seafloor, samples showed sediment carbon had increased over 200% in the restored zones compared to 2016. Because kelp holdfasts and decaying blades were finally adding organic material back to what had been bare rock for a generation. Water clarity readings improved measurably too, from under 10 feet in 2015 to over 30 feet by 2023, since a living kelp forest filters and stabilizes coastal sediment far better than an urchin barren ever could. Charter captains, who had abandoned the area a decade earlier, started bringing divers back, and a small ecotourism economy, built entirely around otter and kelp, viewing tours, began generating an estimated $600,000 a year for the local economy, something nobody had modeled when the project started. The otters themselves had changed too, in ways researchers hadn't predicted. Genetic sampling showed the population, now descended from just 64 founding individuals, had maintained surprisingly healthy diversity, likely because the abundance of food let more juveniles survive to breeding age than in crowded northern colonies. Behavioral researchers also noted something unusual. Otters in the restored bay were diving to depths and durations rarely recorded elsewhere, apparently because the newly complex kelp structure gave them more places to forage and rest between dives, meaning the ecosystem they built was now shaping their own behavior in return. By 2024, 8 years after the first release, the otter population had reached roughly 210 individuals, and kelp canopy covered close to 7,000 acres, nearly half the entire degraded coastline, with projections estimating 70 to 80% recovery by 2028. Countries were already copying the approach. A similar reintroduction began off the coast of Chile in 2022, targeting urchin barrens left behind by decades of otter and sea lion hunting, and early results that were tracking the Washington timeline almost exactly, cleared feeding patches within months, kelp growth within a year. Researchers in South Africa have proposed comparable projects using African clawless otters in degraded rocky reef systems, though funding is still under review. The Japanese Fisheries Agency sent a delegation in 2023 specifically to study whether otters could be reintroduced to restore kombu kelp beds that had collapsed along Hokkaido's coast, a fishery worth hundreds of millions of dollars a year to coastal communities there. Even Canada's Department of Fisheries has opened a feasibility study for 3 additional barrens along British Columbia's coast, citing the Washington data directly in its proposal. The economic case had become impossible to argue with. In 2016, the bay produced nothing, no fishery, no tourism, no ecosystem services anyone bothered to measure. By 2024, researchers estimated the restored kelp forest was providing close to $5.2 million a year in combined value, carbon sequestration in kelp biomass and sediment, storm buffering for the shoreline, nursery habitat supporting commercial salmon and crab fisheries, and tourism revenue, all from a program that had cost a little over $2 million total across 8 years, monitoring included. Today, if you dive into that Washington Bay, you would not recognize it as the gray, spiky wasteland from 2016. Kelp canopy sways 30 feet overhead in places where divers used to describe an underwater moonscape. Rockfish shelter in the understory. Harbor seals patrol the edges, and scattered throughout the forest, otters float on their backs, cracking open urchins on their chests, doing exactly what they evolved to do for thousands of years before humans nearly erased them from that coastline entirely. The program now costs the state about $60,000 a year, almost all of it just monitoring, because the otters, and the forest they rebuilt, no longer need anyone's help. Sometimes the fastest way to fix a broken ecosystem isn't a bigger budget or a longer plan. It's putting back the one animal that already knew how, and then getting out of its way.